Hello, everyone. My name is Samia Ashraf. I am a Flutter developer and a Women Tech Makers ambassador. And I have a very interesting topic for today. It's called platform channels and how we can use native APIs in Flutter. So, if you're wondering what is platform channel, then that is the first thing that we will be discussing today. After which we will move on to the supported platforms and the native languages. That is, what are the platforms that are supported in platform channels in Flutter and their native languages. After that, we will go to the platform specific code. Then we will discuss what are the supported data types and codecs. That is, what are the data types that are supported in different platforms. And after that, we are going to set up method channels on Flutter and also on the native side. Then we are going to listen to events. So we are going to listen to events from the Dart side as well as the native side, the response from the native side. Finally, we will look at an example where we are calling iOS and Android native API from Flutter. So basically, an example where we are going to communicate between the Flutter and the native platform apps. So, first of all, let us discuss what is a platform channel. Now, platform channels, in simple words, is a communication channel through which data can be accessed from the native app. Like, for example, battery information. So if you want to get the battery information of an Android app, then you can access or you can write code on the native app, which is Android, and then get that result onto the Flutter part of the app. So platform channels are basically a mechanism for communicating between your Dart code and the platform specific code of your app. So let's say in our app, we want to get the battery information. We also want device information. And we also want to access the biometrics of the device. Now, most of these already have packages that do the job. But let's say that you're trying to access a feature which does not have a package written for it. So in this case, what we can do is we can write the code on the native part of the app, and then there will be a communication channel, which is a platform channel. And using this platform channel, you can pass the data from the native app and then you can display it in your Flutter app. So, this is where we will be using platform channels. There are so many use cases for this, and some of them are the ones that I mentioned, that is battery channel, battery to get the battery information, device information, and the biometrics. So, in this image here, there is a client app and there is a host app. So client app is nothing but the Flutter app, and the host app is nothing but the native app, which can be iOS or Android. And there is a method channel. Now, this is the method channel through which the communication happens between the client and the host. So there is an app delegate here. If you see in the iOS part of the app, this app delegate is where you're going to write all of the native code. Now, I just said that when we want to access some native specific feature, then we are going to write the native code. Now, in iOS, app delegate is where you will be writing the native code for iOS, and main activity is where you will be writing the native code for Android platform. Now, whatever we write here, that is get the battery percentage for my Flutter app, it is going to look for iOS platform APIs, and one of them will be the getting battery information or getting battery percentage. So it is going to access that information or that method and then pass on to the Flutter app. There can also be scenarios where the Flutter SDK does not have a feature, but that feature is only and only available in iOS, or it is available as a third party API for iOS. Also, those features can be extracted from iOS and then displayed onto the Flutter app. Same goes for Android. You can access Android platform APIs, and you can also access third party APIs for Android and then display it to the Flutter app. So, this is how we can create a communication channel between the client, which is the Flutter app, and the native app, and then extract native specific features and display it on the Flutter app. So, platform channels, I just said that we will be extracting information from the iOS and the Flutter app. So, how does it happen? It happens as messages. So, the data will be passed as messages between the client and the host. And these messages will be through some methods, like, for example, get battery channel method or get battery value method. So these methods, which pass the data from the native app to the Flutter app, are asynchronous. Even the method call to the native app is going to be asynchronous. Now, one thing that we need to note is that between, so first it is the Flutter app or the client that is going to initiate a method. This method will then be received in the host, and then the host is going to execute that method and then pass the data back to the Flutter app, that is a client app. So these passing of message and receiving of message is going to be asynchronous, because there can be situations where um, some of the information extraction is going to take longer time. So that is the reason it is these kind of message passing and receiving are asynchronous methods, just so that the UI does not break at any point. And platform channels are mainly used when when there is a feature which is missing in Flutter, and which is like native specific. Like, for example, it can be accessing the biometrics of an Android app. So these kind of functionalities we can actually implement using the platform channels and write platform specific code either for iOS or for Android. And when I say that we write native specific code, now for Android it's going to be Java and Kotlin, and for iOS it's going to be Swift or Objective C. So that is another thing that we need to note, that when we are writing the native code, the languages will be different, and there are a set of supported languages that we need to note as well. So there can be two ways of communication. One is by calling a method, which is called method channel, and the second one is by setting up listeners, also called event channels. Now, method channel is actually a named channel that is used for communicating with platform plugins using asynchronous method calls. Method channel actually communicates using methods. So, a method will be fired from the client app, which will be then received by the host app, and then the method will get executed. Now, because the methods here are asynchronous, the result is always going to be a future object. It can be a future of map, or it can be even future of list, future of string. It is just a future object. And this is one of the ways of communicating in platform channels. And the second way is event channel. Similarly, event channel is a named channel that is used for communicating with platform plugins, but in this case, it is using event streams, and the data is going to be received as a stream. So method channel uses methods and event channel uses event streams. Now, the platforms that are supported are Android, macOS, iOS, Windows, Linux, and web. So these are the platforms that are supported. And if at any point you want to get the current platform on which the device is running, you can get it using default target platform, which is available in the Foundation library. And these are also the platforms where you can write native specific code. So, as I said earlier, when we are writing the native code, so it is going to be different for different platforms. Like example for Android, the supported language is going to be Kotlin or Java, and for iOS, the supported language will be Swift or Objective C. For Windows, it's going to be C++. Mac OS, it's going to be Objective C. And finally, for Linux, it is going to be C language. So it just means that every native platform is going to have its own native languages, and we can only and only use those native languages to communicate between the host and the client. We cannot write a different language, let's say Objective C on Android, because that is just not going to compile. So, platform specific code. Now, let's say in my program at any point, I want the UI to be, let's say, adaptive. That means when the UI is building, I want iOS, if the app is running on an iOS device, I want a specific information or specific widgets to be shown, then that is when I will be using the platform.is iOS. I'm going to check if the app is currently running on an iOS device. If it is running on an iOS device, then I'm going to execute just that part of the code which needs to be there on iOS app. And for Android also, I can use platform.is Android. Similarly, for web, for macOS, Linux, and also for Windows, I can do the same. I can check what is the current platform on which the app is running and then execute the information. So we will also look at an example for this. Now, one thing that we need to note here is that there is no option called platform.is_web. So if you want to check if the app is running on web, if it is a web app, you need to check if k is web. So k is web is actually a constant and it is exclusively available in Flutter only. So this is a constant using which we can check the app platform, the device platform on which the app is running. And it is always mandatory to check, because if we're running a web app and if we forget to add this if condition to check if it's web or not, then it's going to throw an error. It is going to throw an error because then it is not going to match any of the platforms. So it is always important to check if K is web, to check if the platform is a web platform or not. Now, here I'm just going to apply this, just what we saw now. So here I'm going to get the device type. Now, if the app is running on a web, then I'm going to say I'm going to store the value web on the variable device. If it is iOS, I'm going to store the value iOS. And if it is Android, I'm going to store Android string in the device type. And this example that I have here is actually from an Android device where I'm going to check the battery percentage. So here, and the Android text in this screen is actually a dynamic text. It is coming from the get device type method. So if the same app was running on iOS, then it would say current battery status on iOS is battery level 51%. Now, because this is an Android device, it is going to say Android. Similarly, if it was running on Chrome, it would have said web. And this is how we can use the platform specific code. This is a very simple example that I have here, but you can do a lot more things using this. It can be UI, mostly it would be UI, but you can also use it for other use cases. So these are the platforms, the way we can extract the platforms. We have Android, Fuchsia, iOS, Linux, macOS, and also Windows. So this is how we can extract the current platform. Next, let us explore the supported data types and the codecs. Now, when our Flutter app is communicating with the native app, we are going to write some native code in the native app. So when the data is being passed from Dart to native and from native to Dart, there is a set of data types that are supported. So we need to keep in mind of what are the data types supported, because not every data type will be supported. So here I have for Dart and Java. Now, if I pass a null value from Dart, it will be received as null in Java. But if I pass a bool value from Dart, then it will be received as java.lang.boolean. Similarly, for integer, it will be java.lang.integer. And if in Dart, my integer is 30 bits, 32 bits, if it is not enough in the int, then it will be received as java.lang.long. And if I'm passing a double type from Dart, it will be received as java.lang.double. For string, it will be java.lang.string. So most of it is going to be the same, but here for list, it will be received as java.util.arraylist, and for map, it will be received as java.util.hashmap. So one thing that we need to notice is that from list, it has changed to arraylist, and from map, it has changed to hashmap. So we don't have to convert any of this. The conversion will be done by the asynchronous calls itself. It will be done internally, and we don't have to externally tell that when the list is being passed to Java, it needs to be turned to array list. So the the supported data types, it will be converted by themselves. We don't have to do any part in the code. Similarly, for Dart and Kotlin, it's going to be the same. Map will be received as hash map. And the same goes on for the iOS platform as well. Whenever I'm passing null from Dart, it will be received as nil in Swift, and list will be received as an array, and map is going to be received as a dictionary. So that is the thing. Here in Java, map will be received as java.util.hashmap, but in Swift, it will be received as a dictionary. So there will be a difference in the data types. But again, we don't have to do anything. All of it is going to be handled internally. So next is, so I've been telling you that we can create a communication channel between the Dart and the native app. So how do we do that? We have seen why we need to create a communication channel, and we have seen how the data is being converted from the client to the host and from host back to the client. Now let us look at how the data is being passed. Now, from the from my Flutter app, I'm going to create method channels. So the two possible ways of communication are method channel and event listeners. Let's start with the method channel. So method channel is a way through which the data is going to be passed from the client to the host. And for an example like getting battery information, when I want to get the battery information from the native app, I can actually create a method channel and then use this channel to communicate with the native app. And when I'm creating the method channel, it is always a good idea to have a channel name which when you read it gives you an idea of what the channel is about. Like for example, here I have samples.flutter.dev/battery. So when I read it, I know that this channel is actually used to extract battery information. You will also notice that I've added the app.id here, and that is because I want this channel name to be unique to my app. So in this way, I can ensure that no two channel names will be the same, because when we have two channel names with the same two same channel names, and when they are used together to get the data from the native app, it can actually cause a conflict. So it is always a better idea to have a unique channel name. And then this using this channel name, we are going to create a method channel. This method channel is then going to invoke a method called getBatteryLevel. Now, getBatteryLevel is a method which is present in the native app. So let us look at. So yeah, that is a getBatteryLevel is actually a method in the native app. Now we are going to set a handler for the methods that are being called from native. So in my native app, when I'm going to set up a set method called handler, and this is responsible to check what are the method channels that were passed and what needs to be done. So if you see here, if call.method equal to name of method, so this can be like get battery level. Now, if my call.method is get battery level, then I have to execute the function where I get the battery level. So that example we are going to discuss at the very end. But yeah, so this is basically a method that is going to handle different method call handlers. And if I happen to pass a method channel with a channel name that does not exist, then it will be caught here and an unimplemented error is going to be thrown. So this way I can ensure that the reason for catch is just so that the program does not break here at any point whenever we encounter method channel with a different channel name. So once the method is invoked, and in the native part, when this is executed and when the battery level is extracted from the native app, it is going to be then passed here and stored in result. And this result is going to be a final integer because battery level is going to be an integer. And this result is what I will be using in my Flutter UI, and that is basically how you're going to use the battery level native API. So this is the set method called handler. So next is by setting up listeners. So set up a broadcast listener. Now, like method channels, we can also create an event channel. Again, it is going to have a unique channel name. So it can be samples.flutter.dev/battery, or if you want for device information, it can be device info. So it's always good to have a unique name. And using this, I'm going to create a unique an event channel, and this event channel is then going to receive broadcast stream. So I'm going to set up a listener here, and this when I call this is going to listen to any of the changes happening in the native part of the app. So whenever an event channel is set in the native app, whenever the battery information is extracted, it will be updated, and then it will in my Flutter app, it is going to listen to those changes and then store it appropriately. So sometimes we can call a method before actually setting up the listener. So before creating the event channel, I can set up a listener. Now, in the previous scenario, here the listener is not created because it is created right before the event is fired. But here I am setting up a listener and only then creating an event channel. It's just two approaches of doing it. And they both basically do the same thing. They are going to set up the listener and then create the event channel and listen for the events using the receive broadcast stream. So now let us look at an example. So this is the Android example where I'm setting method handler. And this method handler, just like the one that we discussed earlier, it's going to check if it is a get battery level, because from my Flutter app, I have invoked this method, which is get battery level. So once it receives get battery level, it's going to call get battery level function. So this is the native app. This is actually Android. This is actually Kotlin code. When it receives the method get battery level, it's going to invoke a function which is get battery level and then store the data here. So let us look at what get battery level does. So get battery level is actually a Kotlin function which is initially going to check. It's going to create a variable called battery level, which is going to store the integer battery level. Initially, it's going to check for the SDK compatibility. If it is true, then it is going to go ahead and call the battery manager with battery property capacity. So this is the part where the battery level is extracted from the device, and this is the native code. So once that is extracted, it is going to pass the battery level, which will be stored here, that is battery level. Now we need to check if everything has gone right. So one way we can check is to actually check if battery level is greater than 0. If the battery level is greater than 0, that means the method call was successful. And because battery level cannot be -1, it is going to, if ever it is -1, it's going to say battery level is not available, and it's going to return an error. So so yeah, that is the way we can ensure that the battery level is a is greater than 0 and that it is correct. And if I'm going to pass multiple method channels, then it will be placed here. Because I'm only passing get battery level, I only have one set of if else. But if I had multiple, then I can, after this if finishes, I can say else if, and I can check for some other method which can be get battery info. Else if call dot method equal to get battery info, then appropriate code will be written to get the battery information in the Android app. So this is how we can extract battery information in Android app. This is just for the Android app. And this is where the battery information was displayed. So battery status on Android is at 19%. It was actually at 19%. And next, let's look at the iOS part of the app. So iOS also, it's going to be similar. Once it receives the get battery level method call, it's going to execute. This is the method channel, that is get battery level. And here it's going to execute the method where it checks for the battery level. So this is the function, that is receive battery level. Because if you see here, um, call dot method equal to get battery level. Then it is going to call the function receive battery level. Once the function is fired, it's going to check for the UI device battery state. So again, this is the native code. This is not Dart. So I actually got this from the Flutter docs, but it's going to be different for different scenarios. But if you're looking to extract the battery information, then this is the code. So if at any point the it returns an error, then it is going to say that battery level is not available. Otherwise, the battery level is going to be extracted and then returned back. And this is then going to be displayed in the UI. So this is the iOS native code to get the battery information. And few things that we can note about platform channels is that we should always avoid running long applications because it can actually cause a lot of junk on the Flutter application. So this is one of the limitations. And channel names must be unique to avoid interference. So as I said earlier, if there are two channel names which are identical and but they're doing different things. So let's say battery. I have a channel name called battery, and one channel name with battery is extracting the battery level, and there is a second channel name with battery which is going to extract, let's say, battery information. And if there is a scenario where both these method channels are fired at once, then it can cause undesired output, and there can also be a chance of the program breaking. So that's the reason channel names must always be unique. And another point that we need to note is that every or each native event must have event channel for each and every listener. So that is the another thing that we need to know. And yeah, that was all for the session. Thank you.